Hi everyone. In this video, I'll be reviewing the measurement cat uh, for year 10. Question 1, it asks if the perimeter of this shape is 34.9 centimeters, the value of x is. For this quick question, generally done really well. You need to add all the side lengths and x and equate that to 34.9. So something like this, and that will be equal to 34.9. From here, you can work backwards and subtract 10.8, 5.6, and 8 from 34.9, and you'll end up with x equals 10.5. So mostly really well done. Question 2, it asks for the circumference of a circle with a radius of 3 millimeters. So when calculating the circumference of the circle, we have a formula for that. It's 2 times pi times r. And we know the radius is 3 millimeters, so I'm going to replace that r with 3. This is then a calculation that can be done, and that will give you 18.8 millimeters. So well done to those who got that one right. Question 3, it says, which of the following mathematical statements is true? This question was generally poorly done, so worth having a better look at. Question 3 says, I'm looking for one of these statements to be true. So one thing I can see straight away is that my two shorter sides of this triangle are A and B. So I know that there's going to be a true statement, A squared plus B squared equals C squared. So that immediately rules out option A. Option A does not follow that form. It's A squared equals B squared plus C squared. So look at B. B is the square root of A squared minus C squared in option B. Well, let's quickly rearrange this. I can see that I'm going to get B squared equals C squared minus A squared, and B equals the square root of C squared minus A squared. So again, we can straight away rule out option B. Option C, we can rearrange to get C. If I square root both sides, I'm going to get C equals the square root of A squared plus B squared, which does match our original form. We have just square rooted both sides. So C is the correct solution there. Slightly trickier problem. For the right angle triangle shown, the value of x is given by. Fantastic question, really tricky. We can use Pythagoras' theorem here. So I'm going to write 0.9 squared plus x squared equals 1.6 squared. I can rearrange to get x by itself. So I'm going to subtract 0.9 squared from both sides. I'm going to get x squared equals 1.6 squared minus 0.9 squared. And I have to use a square root to undo the square. So x equals the square root of 1.6 squared minus 0.9 squared. And that matches option B. So nicely done to those who got that one correct. The area of the shape in the following figure is closest to. Interesting question. Not a lot of people got this one right either, but quite interesting regardless. So this is kind of like a Pac-Man shape. So this is a sector. We can see that the angle made by Pac-Man's mouth is 50 degrees. And we can check the remaining angle of Pac-Man. That's going to be 310 degrees. This is really important when looking for the area of these sorts of shapes, because we know that this is some portion of a circle. In fact, it's 310, out of 360 of a circle. So 360 is a full circle, and we're looking at 310 degrees of that circle. I want to multiply that by the standard formula for the area of a circle. So it's pi times the radius squared. So let's quickly calculate that. 310 over 360 multiplied by pi, multiplied by the radius, which is 6 squared. That gives me 97.39, which rounded to the nearest whole number is 97 centimeters squared. So option D is the correct answer for that one. Again, tricky question, and not many people got this one correct. This was a very challenging question. We are looking for the area of the shaded region. And you can see that the shaded region is kind of like a ring. It's like a donut shape. When working the area of these sort of figures out, this is technically a compound shape. So we're looking at adding or subtracting one or more areas. I can see that I have a large circle of radius 5 meters, and within that a smaller circle with a radius of 4 meters. If I subtract the area of one circle of the small circle from the area of the large circle, I'll get the area of the ring. Where the outer radius is that 5 meters and the inner radius is the 4 meters. So let's work this out. I'm looking for the area of the 5 meter circle. That is going to be 5 times pi, that's going to be 5 squared times pi. Pi times the radius squared. 5 squared times pi is going to give me 78.54 meters squared. Let's do the exact same thing for the smaller circle. 4 squared times pi, that gets me 50.27 meters squared. And now I want to subtract them. So I'm going to do I'm going to do 70.54 minus 50.27, and you end up with an answer of 28.27 meters squared. I believe that's an error in the question there. They should read meters squared. So well done to those who got that one correct. Tough question. The next one asks us for the surface area of the square-based pyramid. So when we're thinking about surface area, we have to think of net. So to think of, imagine we can unfold this shape. This is a square-based pyramid. So I'm going to draw myself a little square with some triangular sides coming off. Not too well drawn. That's okay. It doesn't need to be perfect, because we can now look at each of the faces and each of the images in our drawn, our net of our pyramid, and use that to find the total surface area. So I can see from the picture that each of the side lengths of the square are the same, and they're each 4 centimeters. So that tells me the area of the square part is going to be 16 centimeters squared. That comes from multiplying the side length of the square by itself. So I've got 16. I'm going to put that over here to use in a moment. Next, I can see we've got 4 triangular faces. Each of those have a base of 4 centimeters and a height of 3 centimeters. So from our area of the triangle formula, area of a triangle, we know it's going to be half times base times height, which would be a half times 3 times a height of 4, or vice versa, sorry, base of 4, height of 3, and that will give us 6 centimeters squared. However, there are 4 of these triangles. It's a square-based pyramid, meaning each side of our square has an associated triangle. So I have to multiply this by 4 to give me 24 centimeters squared. I'm going to take that and that bit, and I'm going to combine them, because these are all the faces of our shape. The 16 centimeters squared relates to the surface area of the square base, and the 24 centimeters squared refers to the surface area of the 4 triangles. So if you add them together, you're going to get 40 centimeters squared, which is answer option D. Well done to those who got it right. Question 8. The surface area of a sphere of diameter 4 centimeters is. This is a challenging question for sure. We're looking for the surface area of a sphere. We know our radius is going to be involved, and this question gives us a diameter. So we need to make sure we can adjust quickly that diameter and make it a radius. Remember, diameter is the one end of a circle to the other, where the radius is from the center to the outside. So making sure that you divide that diameter by 2 to get the radius. So we're going to have a radius of r, a radius of 2, sorry. The formula for surface area of a sphere is 4 times pi times the radius squared. So I'm going to replace r with 2 in my problem and evaluate this on my CAS. 4 times pi times 2 squared. That gives me an answer of 50.27 centimeters squared. Now, there's a slight issue here. I've given our answer to decimal places. I've given it in what we call an approximate value. But all the solutions here are in exact form, meaning they don't round pi to any decimal places or use decimals. There's 2 ways of approaching this. First one is to check all of the possible options and see which one is closest to 50.27. Or we can identify that what's going on in here is good enough. I've got 4 pi times 2 squared. Well, let's check what's happening here. I have 4 pi times 2 squared, which is another 4. But this is the same as saying 4 times pi times 4. And I can rewrite that as 16 pi. And you'll find that 16 pi is approximately 50.27, giving option D as our answer there. Nicely done. Let's move on to question 9. Question 9 asks for the volume of this triangular prism. Remember, when we're working with prisms, we can, if we find the surface area of the end faces or either one of the end faces, we can then multiply it by the depth, and that gives us the volume. So I'm going to find the area of the triangle first. I can see that I've got a base of 7 and a height of 9. A half times 7 times 9 is 31.5. In this case, millimeters squared. To find the volume, I take this area and I multiply it by the depth. So I'm going to have 31.5 times 21. And that gets us an answer of 661 millimeters, or 0.5, sorry, 661.5 millimeters cubed. And answer option of D. The method used here works for any prism. If you find the area of one of the ends and multiply it by the depth, that is your volume of your prism. Question 10. A prism has a right-angled triangular base with sides 3, 4, and 5. The prism stands 12 centimeters high. The volume of the prism is. This is a very tough question. Quite challenging. This stems from a little bit of prior knowledge with Pythagoras' theorem, however. 3, 4, 5, they form a right-angled triangle. So you would have needed to remember that 3, 4, 5 as the sides of a triangle create a right-angled triangle. That's a guarantee. You can verify that yourself using Pythagoras' theorem. So, using this information, we can find the area of the triangle. I can see I've got a half times a base of 3 and a height of 4. So that's going to give me an area of 6 centimeters squared. However, this triangle is 12 centimeters high. So it's a triangular prism, much like the last question. So I'm going to take my 6 my area of my face, and multiply it by how far or how deep it is. In this case, it refers to height, so keep your mind open to those possibilities. Multiply it by 12, and I get a volume of 72 centimeters cubed, which is answer option D. Okay. Question number 11. Convert the following units as indicated. There's several ways you can do these questions, and I'll show you what I think to be one of the quickest and easiest ways. Converting from centimeters to kilometers directly, I find quite challenging, so I'll do one step at a time. Converting 235 centimeters into meters is equivalent to dividing by 100. So I divide this answer by 100, and I get 2.35. Converting meters into kilometers is equivalent to dividing by 1,000. So this seems more like a job for your CAS calculator to do. But this isn't too bad. You'll get an answer of 0.023, oh, one more zero, 0.00235 kilometers. Nicely done. Question B. 200 millimeters squared to meters squared. The conversions for millimeters squared and meters squared and all other squared units is really, really similar to the non-squared. So let's have a look. 200 millimeters squared. Again, I'm going to go step by step. I'm going to convert 200 millimeters squared into centimeters squared. When converting millimeters to centimeters normally, you divide by 10. However, when you're dealing with centimeters and millimeters squared, you divide by 10 squared. So let's have a look. Dividing by 10 squared will be the same as dividing by 100. So that's going to give me 2 centimeters squared. In a similar way, when converting centimeters squared to meters squared, I divide by the regular conversion squared. So the regular conversion from centimeters to meters would be dividing by 100. So you're going to divide this by 100 squared. And that's going to leave you with 0.0002 meters squared. Nicely done. Question C is apply the same principles. I have 32.45 kilometers cubed, and I'm going to convert this first into meters cubed. Converting kilometers to meters, you multiply by 1,000. So kilometers cubed to meters cubed, you times by 1,000 squared. So solve it quickly, 32.45 times 1,000 cubed. In this case, my apologies, I know I said squared a moment ago. We are looking at units cubed, so we cube 1,000. We end up with 3.245. My calculator is giving me some scientific notation, so I'll write that in. I'll also write it in as an expansion. Oops. Quite a large number, as you can see. And it only gets bigger. To go from meters cubed into centimeters cubed, you multiply by 100 cubed. So in a similar way, meters to centimeters is times 100. Meters cubed to centimeters cubed times 100 cubed. So let's do this in scientific notation first. Times 10 to the power of 10. That's in meters cubed, and in centimeters cubed, it's 3.245 times 10 to the power of 16 centimeters cubed. Written in expanded form. Hold your breath. Let's count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 centimeters cubed. So as you can see, a lot of centimeters cubed. Very nice. Generally okay, that one. Not too badly done. Question 12. It asks you to find the perimeter of the following shape. 2.8 as of the base and 7.2 millimeters for your sides. Those double dashes mean that those sides are of equivalent length. So as I find the perimeter, in this case, I will add 2.8, 7.2 to 7.2. So my CAS, 2.8 plus 7.2 plus 7.2, that gives me a value of 17.2 millimeters. Not too bad, quite well done overall. Find the perimeter of the following correct two decimal places. So this is now asking for the perimeter of a circle, which has another name. It's known as a circumference. We have a formula for circumference. It's pi times the radius times 2, or more commonly written as 2 pi r. So this one's not too scary. This is what we call a plug and chug. I'm going to have the radius of 18 multiplied by 2 times pi. And if you plug this into a calculator, 18 times 2 times pi, it asks for your answer to two decimal places. You will get 113.10 meters. Very important, even though when rounding, you're left with 10, it asks for two decimal places, so you must include the additional 0. Definitely worth checking out. Question number 14. Find the perimeter of the following shape, correct two decimal places. Challenging question, but we're going to use a similar principle from sectors earlier. We can see that the angle on the inside of the sector is 145 degrees, and that's out of a total of 360. I'm going to multiply that by the circumference of the full circle. That's going to give me the portion of the circle that spans 145 degrees. So it's going to be 2 times pi times r. And I'm going to save some time and replace r with 2.4. That gives us the curved part of the perimeter. We must also include the two radii, so the lines going from O to B and from O to A. So I'm going to add 2 times 2.4. Now, I can hear the calculator saying this is a job for me. So let's put that into the calculator. 145 divided by 360 times 2 pi times 2.4 times plus 2 times 2.4. And I get an answer of 10.8737, rounded to two decimal places, 10.87 centimeters. Just a note as well, if you think you put the correct answer in, you did lose a mark for not putting in the correct units. This is a perimeter question, so a length, so your units will be centimeters. Find the length of the unknown side. This is question 15 and relating to Pythagoras' theorem. Let's get straight into it. I can see that my two shorter sides are 12 and 9. So I'm going to do 12 squared plus 9 squared equals c squared. I'm going to evaluate my left-hand side. It's going to become 144 plus 81 equals c squared. 144 plus 81 is 225, and that equals c squared. I square root both sides. So the square root of 225 will equal c. And the square root of 225 is approximately 15. In fact, it is exactly 15. So 15 was the correct solution there. Well done to those who got that one right. Let's keep moving along. Question 16, another Pythagoras question. It's part of the same principle. In this example, though, I can see that my short sides are a and 5. So I'm going to write Pythagoras' theorem with that in mind. A squared plus 5 squared equals 13 squared. Cool. We want to find the unknown value, so we want to find a. So we should rearrange our equation to give us a equals. So let's start by subtracting 5 squared from both sides. a squared equals 13 squared minus 5 squared. Nice. And now I'm going to square root both sides to get rid of the squared on a. So that's going to be a equals the square root of 13 squared minus 5 squared. This is a job for your calculator, or if you're feeling lucky and feeling brave, you can have a go by hand, which I will do. 13 squared is 169. 5 squared is 25. 169 minus 25 is 144. And the square root of 144 is 12. So 12 is the correct solution for that one. Challenging question. Well done to those who got that one correct. Question number 17. Find the area of the following shape. This is a triangle. This isn't too bad. We are looking for the area. This has a standard formula. Area is a half times the base times the height. So I can see I'm going to have a half times 5 times 11. Job for the calculator. 1/2 times 5 times 11 is 27.5 centimeters. Centimeters or centimeters squared? This is an area. It's going to be centimeters squared. And that is the correct response for that question. Question number 18. Find the area of the following shape to the nearest whole number. So it might be a bit difficult to tell what sort of shape this is, but this shape looks to me like a parallelogram. And when dealing with parallelograms, it's actually very similar to the area of a triangle, base times height. Now, the image looks a little bit skewed on my screen, but the base here will be 9.7 and the height is 3.4. No need for a half though, because we're using a full parallelogram. Multiplying these two, you get 32.98. Very important to note that the question asks for the nearest whole number. So our answer will be rounded to 33 meters squared. Well done to those who got that question correct. Question 19, find the area of the following shape correct to 3 decimal places. This isn't so bad. This is the area of a circle, and we've seen the formula for this already. It is pi times the radius squared. But again, note in this question that we aren't given the radius, we are given the diameter. We are given from one end of the circle through the middle to the other side. So we know that that needs to be divided by 2 in order for a radius. 7.5 divided by 2 is 3.75. So pi times 3.75 squared. It's a job for your calculator. Pi times 3.75 squared. That gets you an area of 44.18. 3 decimal places. 179 centimeters squared, which is the correct solution for this problem. Again, slightly more challenging, so well done to those of you who got it correct. Question 20. Find the area of the following shape. Good question. I like it a lot. There's a lot of things happening here. I can see this is kind of like a house shape. I can split this up, however, into 2 shapes. A rectangle with area of 10 meters times 5 meters. So let's work that out really quickly. Area of the rectangle is 10 times 5, which is 50 meters squared. Not too bad. And I can also split it up into an area of the triangle. Area of the triangle is going to be a half times the base, which is 10, across the bottom of the shape, or the bottom of the triangle, times a height of 4. And if you check this, you'll get an area of 20 centimeters squared. This is a composite shape, so we will combine these areas, and you'll get 70 meters squared. My apologies, I've written centimeters squared here. We are working in meters squared. So the area will be 70 meters squared. Question 21, quite poorly done overall. It was a tough question. Here though, I can see that it's practical to split this into two rectangles. There's several different options for the size of rectangle. And another thing to note as well is that we have different units in this question. So I'm going to split this up into two rectangles. And let me show you what they look like. I'm going to try and draw it out over here. Okay, it's kind of like that, my shape. I've got 30 millimeters here. I've got 15 millimeters here. I'm going to convert 4 centimeters into millimeters to make it a little bit easier for me to work with. So I don't have to switch units halfway through. And I'm going to split my rectangle down the middle, just like that. So I'm going to have area number 1 and area number 2. Area number 1 is rather easy to work out. Area of shape 1, it's a rectangle, it's length times base, or length times height. So 15 millimeters times 40 millimeters, give me an area of 600 millimeters squared. So look at area 2, slightly more perplexing. I'll give you a moment to have a think about it. You may see we run into a brick wall here, and there's actually some information missing in my diagram. I am missing these dashes. That tells us that this length here is 30 millimeters straight, which is really important because we can use that information to find the missing width of this shape. I know that the width of this shape is going to be 30 millimeters from here, plus 15 millimeters from here. That's quite helpful. I can also use to work out the missing height. I can see that the entire height of my shape is 40, and I can see that this portion here is 30, meaning there is 10 left over here. So this rectangle number 2 is 30 millimeters by 10 millimeters. That is 300 millimeters squared. Combining these two areas gets you 900 millimeters squared. Another valid response would be 9 centimeters squared. If you converted 30 and 15 into centimeters, this would also be a correct answer, as these are mathematically equivalent. So nicely done to those who got that question correct. Question 22, find the surface area and volume of the following shape. A couple of you seem to miss the memo when it says and the volume. So let's look at the surface area first. I can see that there are two rectangles that have area 2 centimeters by 4 centimeters. Those are the two end pieces of my rectangular prism. I can see that there are two rectangles. Let's try to draw this. Of length 12 centimeters by 4 centimeters. Looking at the shape, those are like our top and bottom pieces. And I can see that there are two panels of, so we can draw this. Yeah, it's not too bad. 12 centimeters by 2 centimeters. These are our two side panels. If I can find the area of each of these, multiply them by 2 and add them all together, that'll give us the total surface area of this shape. So I can write an expression that makes it a little bit easier. 2 times 2 times 4, that is dealing with this, plus 2 times 4 times 12, that is dealing with this, and 2 times 2 times 12, that deals with this. Let's quickly do that on my calculator. 2 times 2 times 4 plus 2 times 4 times 12 plus 2 times 2 times 12. That gives you a total surface area of 160 centimeters squared. So that was worth 2 marks, 1 mark for the correct number and 1 mark for the correct units. For the volume, there's many ways you can calculate it, but I'm going to use one way. I'm going to use the area of my 2 small end faces and multiply them by the appropriate depth. So I can see the area of my small face is 2 centimeters times 4 centimeters. Save you some time. That is 8 centimeters squared. And now for the volume, I'm multiplying 8 by the depth of 12. So that goes right from the front all the way to the back. And 8 times 12 gives you a volume of 96 centimeters cubed. So 160 centimeters squared is correct, and 96 centimeters cubed is the correct volume. There was no one, I believe, there's a few people who got both parts correct. So nicely done to those people. This is our final question, I believe. This one was generally not well done, so worth having a real good look at. We're looking for the surface area and volume of the following shape. So, surface area first. This is a cylinder, so I can see that there is a curved surface, which we'll calculate second, and 2 circular ends. Let's calculate those really quickly. So, for the area of the circular ends, I know my radius is 1.5, and the area is pi times the radius squared. So pi times 1.5 squared. Let's get an answer for that. Pi times 1.5 squared. That is approximately 7.07 millimeters squared. But there are 2 of them. There's 1 on each end. So I'm multiplying that by 2 and getting approximately 14.14 millimeters squared. Now, for our curved surface, you can imagine that I cut a line from one end to the other and unroll it, kind of like a toilet roll. And what you'll end up with is you'll end up with a rectangular shape. Let me try and draw this somehow. So imagine I get a pair of scissors and cut along here, all the way down, and I unroll this shape. So I'm going to end up with a rectangle like this. For clarity, this edge along here is equivalent to the circumference of that circle up there. And similarly, that bottom edge is the same as the circumference of the circle down here. These 2 sides are our cut mark. Where we cut our shape from top to bottom. Okay. We can see that the height will match the height of our cylinder, or in this case, it's lying on its side, so the length of our cylinder. That's going to be 6.7 millimeters. The top and bottom edge of our rectangle are the circumference of the circles that are on either end of our cylinder. So I'm going to find the circumference of that circle. 2 times pi times r, which is 2 times pi times 1.5. That gets you a length of 9.42. So I'm going to put that over here, 9.42 millimeters. And I'm going to multiply them now. So 9.42 times 6.7. That gets you an area in here of 63.15 millimeters squared. So now it's time to combine our 2 circular ends with our curved face. 14.14 plus 63.15 gives you a total surface area of 77.28 millimeters squared. Very nice. Volume is something we've seen before and done a similar sort of question to. This is technically, it's never called this is a circular prism. So you can find the area of the circular face on either end and multiply it by the depth. So let's find the area of the circular face. It's going to be pi times the radius squared, pi times 1.5 squared, and on the cas, 1.5 squared, that gives me 7.06. Beautiful, 7.07, my apologies. We worked that out a moment ago up here as well, and that's millimeters squared. I now need to multiply that area by the depth. So 7.07 millimeters squared times 6.7 millimeters. You will get a total volume of 47.36 millimeters cubed. And that there is the final answer for part 23. Thank you for watching. I hope this review was helpful for you in your revision. If you have any questions, please let us know. Thank you so much. Have a good night.